To run an Arc Flash study, we're going to create a new project similar to what we created before, but this time we're going to add some protective devices to our one-line diagram. Just like before, click on New Project, and this time put AF for the name of the project as an Arc Flash. Once the project is created, switch into Edit mode and turn on the grid line. This time we're going to lay down a one-line diagram similar to the first example, but in this time we're going to add protective devices. Protective devices are responsible to clear and seal the fault and not letting the fault currents leak into upstream and damage the rest of the power system. This will lead to another study which is called Protected Devices Coordination Study, which we are going to cover in the next videos in detail when it plays a very important role in the design of the power system. Now let's start creating our one-line diagram by simply putting the same elements as before. Again, we're going to need another power grid, 2-winding transformer, a bus, and this time we're gonna put an induction motor to see how induction motors work, and this time we're gonna put a low voltage circuit breaker because in this example I'm gonna set the settings for the power grid for 4.1 kilovolt, 100% voltage operation, and short circuit would be infinite, 6 for the impedance, and okay. And the transformer secondary voltage, as you see, the primary voltage is 4.1, and secondary I'm gonna put a low voltage of 480 volt, and has 1500 kVA, and the impedance in this case would be 6% as well, and let's fill the rest as typical. And let's connect this transformer to the bus. So as you can see, the bus 2 voltage would be 480, and let's extend the bus and connect the circuit breaker to this bus and the other side to the induction motor that we have. And I'm gonna so this time, if you look at the settings for the induction motor, we have the info, which is the same as other equipment that we have confronted so far. So let's switch to the nameplate. This is where we are going to assign the horsepower for the induction motor. In this case, I'm going to put 50 horsepower, as you can see. And when you click somewhere in the window pops up, which is asking about the full load amp, and it asks about the calculation, which one you want to put as a base. And this time I'm going to put the National Electrical Code, which says based on NEC, the full load amp for the 50 horsepower induction motor is 65 amp. The power factor would be 90.39%, and the efficiency is 79.65, and the kVA is 51.78. Let's select this one and click on OK. And another new element that we used for this example is a circuit breaker, low voltage circuit breaker. Let's double click on that and change the settings. Okay, so again, the info has so many fields in common. It says it's connected between which buses, the bus 2 and the motor. Let's switch to the rating tab, and this time we're gonna choose a trip device from the library. As you can see, ETAP has a good library of circuit breakers and trip devices. From the manufacturer field, I'm gonna choose, for example, Cutler hammer. And for the model, we're gonna choose something that covers the 480 volt. So for the 3-pole, let's choose the EDC model. Max kV would be 0.6, which is good, and 3-pole. Now about the size of this breaker, we're going to choose one with the amperage rating that covers up the full load amp of the motor, which, as you remember, was 65 amp per NEC. In this case, I'm going to choose 80 amp and click on OK. Now what we're gonna do is leave the rest of the fields the way they are for now and click on OK. Now one element which is missed is the bus that we're gonna put as a terminal of the motor. So we're gonna delete this connection and put this bus in between the breaker and the motor. The reason why we added this bus is because this bus is our motor's terminal bus, and we're gonna have this bus faulted to run an arc flash study. Now to do so, we're gonna switch over short circuit analysis mode, and we're gonna right click on this bus, and as you can see, the first option is to fault this bus, and we're gonna click on that. Now as you click on somewhere in the window, you will see that the color of this bus is reddish, which means that we already put this bus in fault. Now again, click on the yellow triangle, which is run arc flash. As you can see, and warning page pops up which says in order to get the right and true PPE requirement, we have to approve the PPE. So based on the latest standards, as you can see, NFPA 70E, so let's click on OK. As you can see, we have the information here for the arc flash. The information that is showing here is the arc flash boundary, which is 1.35 feet, and the incident energy, which is 0.97 calorie per centimeter at 80 inches distance. As you remember, we talked about this. It means that if somebody stands at the 18-inch distance from the source of the incident, the energy level at that distance would be 0.97 calorie. And as you can see, the short circuit current is 19.64 kiloamps as well. So now back to the approval for the PPE. We may hover our mouse over edit study case, as you can see the red briefcase, and click on it. And this is the window for short circuit study case. We switch over arc flash data. As you can see in the middle, we have the PPE requirement, which by default the NFPA 70E 2012, in this case the latest one, is selected. So what we do is click on edit approve PPE, and as you can see, based on this version of NFPA 70E, it defines all the levels and different range of energy levels categorized. And as you can see, the level A, for example, is where we have energy, incident energy up to 2 calories per square centimeter. The level B is where we have up to between 2 to 4 calories, and so on and so forth. So what we're gonna do, we're gonna just click on approved PPE and check the PPE requirement approve. As you can see, the screen is locked. It turned gray. It means that we approved it. So click on OK, and again OK. So now if you run the arc flash study again, you won't get that warning message no more. So once again, we have the arc flash results next to the faulted bus. Now if we want to show different results next to our one-line diagram, as before, we can open the display options menu, and in the first tab, as you can see the results, we can play around different options that we have and put the more and less results next to our one line. In this case, for example, if you move your cursor down to arc flash field, you can see two of the fields are already selected, which are the arc flash boundary and incident energy that we talked about. We can add two more fields to the results, which are energy levels and fault current terminal, or FCT. And you may also decide whether you want to see it in the cycles that it takes for the fault current to be cleared, or in seconds. In this case, I'm going to leave it as seconds and click on OK. And as you can see, the results are now modified into 4 different fields. First, the level A, which is because the incident energy is dropped in the range of 0 to 2 calorie per square centimeter. As you may remember, when we approved the PPE for NFPA 2012, we had level A assigned for incident energies below 2 calorie per square centimeter. And the second one is, again, arc flash boundary. The third one, incident energy. And the fault current time is added to the result, which is, in this case, 13 milliseconds. Now together, let's generate one arc flash label for the faulted bus. Let's double click on the bus 3, which is the faulted bus, and switch over rating tab. In this tab, at the bottom part, the shock protection, as you can see, the default numbers are set to 0, but these are the boundaries that we already talked about. The limited approach boundary, restricted approach boundary, and prohibited approach and boundary, which we're gonna choose the typical data, but first make sure that the data option that is already chosen make sure this typical data are based on the latest NFPA standard by clicking on data option. But let's first make sure that this typical data are being fetched using the latest NFPA codes. By clicking on data options, we will see that the shock hazard analysis data is based on NFPA 70E 2009 and 12, and also the arc flash analysis data is based on IEEE 1584 2002. So now click on OK and click on typical data, and you may now see that the boundaries changed based on the typical data from NFPA and IEEE. And then switch over to arc flash tab, and in this window you can see that ETAB automatically calculated the amount of energy and all the information regarding the arc flash for the faulted bus. But you may switch to user defined mode on the right side and put your info and put your input based on your calculation as well. ETAB gives you this capability to put your own data. One other thing that is important is the working distance. All these calculations are based on whatever you put and choose for the working distance. In this case, I put 18 inches, but if you drop down the list, you will see that you have other typical working distances that you can switch between. But for now, let's stick to the 18 inches. Finally, we can print the label, but first we have to choose in between the variety of choices that we have based on the dimensions of the labels and the information that we want to use in the industry. And one of the typical labels are the 3.5 by 7 inches Danger labels, which in this case I'm going to choose that one and click on print. ETAB automatically generates the label. As you can see in this window, we have the label for bus 3, which is the faulted bus, and the category of the incident, which is 0, as we talked about, and we have all other fields filled by ETAB automatically. One of the good options that we do have now is that we can export the report by simply clicking on the export report icon on the top left corner. This gives us the ability to generate and export this label to other extensions like PDF and Microsoft Word editable and so on and so forth. As you can see in this list, you can choose from the options that you do have for the exported file. But as an example, let's create a PDF label and click on OK. It will then ask about whatever pages you want to be inside the PDF exported file, but in this case we only have one label, so we're going to stick to all and click on OK. And then ETAB asks about the location of this PDF file. We're going to put it on the documents folder for now and click on save. And then now if we cruise over documents, OneDrive documents, and here it is, the PDF file of our ArcFlash label. And last but not least, using short circuit analysis in ETAB, you can simply put a fault anywhere in your power system and ETAB automatically shows you the next trip device that would trip and also the information about the ArcFlash. Just click on Run ArcFlash Fault Insertion Calculation. You will see the ArcFlash sign at the cursor of your mouse. The color of this ArcFlash sign is black, and as soon as you hover it over the bus that you wish to fault, it turns yellow. That's when you can just click your mouse and ETAB would show you that the next protective device that would trip would be this circuit breaker, and also it gives you the fault clearing time of this incident, which was 13 milliseconds as you remember, and incident amperage regarding this fault would be 19.44 kiloamp. In future episodes, we're gonna create bigger projects with more levels of power flow and also more protective devices. And with those examples, you will get a better idea about how to set your protective devices setting in order to have the correct